Welcome to Homework Lib.
Okay, so when you're doing a double slit experiment, right, let me draw this. So here's your double slit, right? And there's these two slits, they're separated by distance d, and there's a screen over here that you get these spots showing up on. There's a bright central spot, and then there's less bright spots further away, right? The distance between these bright spots is called x sub m, right? And this screen is some length L away, and M is the order number for these spots, right? So right here, this is the M equals 1 spot. Right here, this is M equals 2. And if you remember, whole integers equal bright spots, and half integers equal dark spots, right? So this is M equals 1 down here. This is M equals 2, and so on, right? And if I wanted dark spots, I'm going to do dark spots in black. So this dark spot here would be M equals a half. Same thing here. This would be M equals a half. And then over here, it would be 3 over 2. And then here it would be 5 over 2, right? Okay, so knowing this, there's a relationship between all this. Xm equals M lambda L divided by D, right? And this comes from the small angle approximation and all that, but this is a common formula for this. So if you look at this, if it's telling you I have light of a wavelength of 600 nanometers, and it gives me an interference pattern, first order bright fringe, so M equals 1 at 4.84 millimeters, right? So XM is going to be, that's XM, 4.84 millimeters. The question is, what wavelength at the first dark fringe? So basically the wavelength at the first dark fringe is going to be M equals half. So if you look at this equation, right, if I plug half in for M, in order to keep XM the same, right, to keep that distance between the central fringe and the fringe I'm looking for, I would need to double the wavelength. So for a wavelength of 1200 nanometers, I would have my, first dark spot at 4.84 millimeters, right? And so you can do this and solve. You can plug in M lambda L over D, right? You can plug in a half here and 2 here, and you're going to end up, this number's constant, this number's constant. You're going to end up with the same XM, right? Because a half times 2 is the same as 1 times 1. So 1200 nanometers.